Good morning, beautiful and handsome students. Welcome to CalcuLearning. I am Miss Giachon, and today, my fellow teachers and I are going to tackle about one of the fundamental topics in calculus, which is finding the antiderivative of the function. Mr. Vergara, could you explain to us what is integral calculus?
Integral calculus is concerned with finding the area under a curve. It is the reverse of differentiation, which means that we find for antiderivatives. If f is an antiderivative of f of x, it is equals to f of x plus c. The integral sign and the dx go hand in hand, and the dx helps us identify the variable integration. There are two types of integral, which are indefinite integral, which is the equation I mentioned earlier, and the definite integral. Thus, finding antiderivatives is just like finding derivatives. We use such mathematical theorems and rules to solve the answer for more efficiency and to be able to answer it more efficiently.
Very well said, Mr. Vergara. For integral calculus, let us have this one example. Students, find the integral of the equation 2e to the x minus 5 over x cubed. Quite tricky, isn't it? We have here Miss Malinaw, Mr. Vergara, and Miss Ortiz to solve for its antiderivative.
First off, we need to separate the integrals individually. This applies the fourth theorem when it states that if f and g are functions defined on the same intervals, then it is equal to the antiderivatives of f of x plus or minus the antiderivatives of g of x. And since 2 is a constant with respect to x, move 2 out of the integral. This applies theorem number 3, wherein it states that if a is any constant and f is a function, then the constant number is outside the integral sign. The integral of e to the x with respect to x is still e to the x, wherein this applies the first integral theorems, an exponential function, that states that the derivative, or antiderivative rather, of e to the x is equals to e to the x plus c. Since negative 1 and 5 is constant with respect to x, move negative 1 and 5 out of the integral, which applies theorem number 3 of integrals. Then multiply them with each other, which makes it negative 5 outside the integral.
Afterwards, move x cubed out of the denominator by raising it to negative 1 power. Multiply the exponents 3 and negative 1, and the product is negative cube. Next, we have to apply the theorem 2 in integrals, wherein it states that if n is any real number and n is not equal to negative 1, then the antiderivative of x raised to the power of n is equals to x raised to the power of n plus 1 over n plus 1 plus c.
Now let me show you how to get the antiderivative of x negative cubed and apply theorem 2. So our numerator would be x raised to the power of negative cube plus 1, and our denominator is negative 3 plus 1. Next, add exponents together and the denominator values plus c, or we could simplify it to negative 1 over 2 squared plus c.
In our solution, we will change x raised to the power of negative cube by its antiderivative. Then, we simplify the answer, in which we have 2e to the x plus 1 over 2x squared plus c as our final antiderivative to the given integral problem.
Thank you so much, Mr. Vergara, Miss Malinaw, and Miss Ortiz. Hope you guys have learned something from today's session. Once again, this has been Miss Giachon, and always remember, with CalcuLearning, it's amazing. Until next time, bye!